Hello, welcome to this tutorial. I'm Maurice Dimba, and today I'm going to take you through the pre-engineered building system in Tekla structures. In Tekla structures, we have a particular tool called PEB macro or PEB system tool that simplifies the modeling and design of these particular structures. And normally, pre-engineered building system has numerous advantages. Number one, it is faster to construct, and number two, it is earthquake resistant since it is seismic design. Number three, it is economical when it comes to project funding. Number four, it is space flexible when it comes to larger spans. Now let's get started right away, and if you take a look on the screen here, you can see a grid already in place and some small structure beside it. Now I want to go straight to one particular tool under PEB. In this particular case, we have these are the tools for PEB. If you can manage to download this from the site, and you can be able to apply this or use this to create a building system tool, a pre-engineered building system in Tekla structures much faster and easy. Now I'll double click on this PEB frame, and this tool and this dialog box will pop up, and here is where I'm going to set up my frames. Now if you take a look, let me just drag it slightly aside, and I'll come to the first tab here written frame, and this way I'll set my span and the splice lengths and other parameters. Now I'll start with the span. My span here is 33.9 that, and here I'll just change that to 0, and I need height, eve height of 7 meters high, and this one I'll change it to -150. I'll explain that as we go, and let me just get half of this 33.9. now I'll feed here 16,950 right there. So this I'll change to 0, and I don't need any gable columns right here. I'll just change it to 9, and to be sure of that no gable column will appear, I'll just have to get rid of that. So what do I need next? And the reason why I'm placing a -150 is because I want to change this tapered column. The top end here will be 600, and the bottom end here will be 300. So to make this 33.9 match the center to center of these tapered columns, I have to give that offset of 150. Now I'll come in and check or select the frame type. I'll click this drop down arrow here, then pick this one here. I'll go ahead and click apply that, then go to the second tab where we have frame parameters, where we can set the parameters of this particular frame. So I'll go ahead and click it right there. So we have number one, column 1, column 2, and rafter 1, rafter 2, and ridge rafter here. So I'll go to the first option where I'll select on column 1, and under column 1 I don't need any splice joint or connection there. So what I'll do, I'll just click on this drop down arrow and select none. So I'll go to the next column and click this drop down arrow, then select none at all. Then we come to rafter here. I'll pick on rafter 1, then I'll need splice joints around 2, but I'll set the span of the lengths. Now I'll prefer 7 meter length, so I'll copy all these to all these fields here labeled 6 meters or 6,000, which means we are in meters. I'll select that and paste on all these. I'll paste it everywhere on these fields here. I'll select that, then I'll go to the next rafter number 2 and do exactly the same thing. I'll paste these distances of 7 meters on inside these fields. Now once you've pasted that, just paste that, we'll go to ridge rafter, which we have nothing to do, so just ignore these interior column parameters, and we'll just go ahead and apply that. apply that. And prior to applying anything, please go back and check whether your frame parameters have the exact measurements that you really intended to apply on this particular structure. So in this particular case, these are the exact measurements that we intended to use for this particular PEB building. Now I'll go ahead and click apply and come here and pick the points where I need to span my structure. I'll pick on the button pick. Then if you take a look on the bottom end here, you can be able to see pick origin point of PEB frame. So I'll pick this particular point as my first point, then go to the next point here. So I'll snap right here, and once you snap on that on the second point, come here and click this button create. Then the moment you create, you give it some time to process that information. Then another dialog box will pop up around here, and whatever you are required to do is just to click OK. Frame are inserted, and go ahead and click OK, and go ahead here and click OK. So if you zoom out, this is what we expected to see. So in this case, I'll get rid of this dialog box here because it's now an obstruction to whatever we want to do. So I want to rotate this, and the easier way to rotate it, we have two options through the keyboard shortcut, and on menu option here, we just click on navigate and scroll to rotate with mouse, and select rotate with mouse and pick rotation point. Just select on that particular point, then press your left button on the mouse and rotate this comfortably like this. Now we want to change these columns to tapered columns. Now what we are going to do is just to double click on it, here, and just drag this dialog box. In case it's obstructed on your screen, just drag it to a visible place. Then we want to change, we want to taper this column. We want to create a tapered column here. So what we'll do, we'll come to depth definition section here. So we'll select the first option here, change this to 300, then click modify, and you'll see this column being tapered, or taking a tapered shape. Apply and give it an OK by pressing an OK button right there. So we want to do the same to this end. We'll double click and wait for that dialog box to appear, and come to depth definition section here and change this to 300. Modify, apply, and accept by clicking an OK button. Right click and redraw, just to remove any signs of modifications. Then come to rotate and turn this around and check whether these columns are sitting at the centers of the points that you defined previously. Sometimes it's really tricky to position the PEB frame on a grid that you defined. Sometimes it clashes, and if you worked out your parameters correctly the way we did here, it will match exactly that. So it normally comes when the top end of your tapered column, in this case here on top here is 600, and at the bottom end here is 300. So whatever I did, if I come back here and double click on this, whatever I did is, since here we have 600, and the bottom end here we have 300. So whatever I did, I just fed in the half of the bottom taper of 300, which is 150. So I prefix that half of 300 by a negative sign, so that will pull it right to the center of this. Now whatever I've done, it's very simple. Now whatever I did was very simple. It's just to feed in this half of the bottom end here, which was 300, and prefix that with a negative sign. This will pull this column right to the center of all of this grid. Now let me just get rid of that and get rid of this. And what I'm going to do now is to set up these splice connections. Now let me first of all start with the at the haunch here. I'll double click on it. Then I want to modify further on how the connection appears or looks like. Now once you've double clicked on this connection right here, I'll come to parameters here, and nothing we can do here. We just you either select the appropriate connection of your preference, and in this case you just leave it on the default connection. Now just click on empty screen or aside or next to it to let the selection disappear. Then come to parts. Under parts here, what you want to do here is just to feed 300. Just feed 300 here and click modify. You want this plate to be 300, and thickness you just leave it with the default thickness. Now I'll come to bolts here. Under bolts, I'll change this to M20. I'll select M20 and I'll select that 8.8 XOX, and here I'll feed 150 and to 150 to by 150, and I'll go ahead. Let me just change that to times 150. That's okay. I'll go ahead and click apply or modify. Apply once again and try to come to navigate and try to turn this around whether this sits well or connects well with this particular section. You can see this member is black, and we really need some sort of uniformity. So what we'll do is first of all disable the assembly, then come here and select on that, then come to navigate, and we want to rotate this so that we select the end, then press Control, double click on that. Then we have to change this. We have to give it a different color. So we'll select class, we give a class color 3, class color code 3, and that will change to green. Now let me go to the other end, since we've changed this connection and it looks like this. And this is the beauty using the PEB macro. It makes your design looks much professional, and it's easy to model and design this PEB building system. Now let me go back to this end and finalize with this column section. Then first of all bring back my assembly here by selecting that select component button, or enabling this select components button here. Now I'll double click on this once again and come to parts and change this to 300, and click modify, apply, and give it an acceptance there by clicking OK. Now I'll double click on this once again and come to parts, and that's okay. We come to bolts and feed here 150 and 2 by 150, and that's okay. We change the bolts M20 and the bolt grade of 8.8. That's okay. We need some washer right there, and go ahead and click modify, apply, and give it an acceptance. And you need some more uniformity. You don't need this black plate. Now just to select on that, press Control and come to navigate here and select, come to navigate and select on that, right click and press Control and double click on that and change the class code color to 3. Click modify, apply, and give it OK. That is it. That's it. Now if I turn this around like this, this is what we have. This is exactly what we have. And now the next move, we are going to splice connections, and here we have to feed in our appropriate connections or our preferred splice connection for this particular span. Now I'll double click prior to double clicking, make sure your assembly is intact. So in this particular case, we've dismantled the assembly. So if you click on this, you will be able to select these components. You'll be able to select individual components on this particular section. So we want to select this as a joint. Now whenever I enable this button here, I'll be able to select on this splice as a group. Now I double click on that. So I want to modify this. I'll feed here 90. Is dependent on particular depth of your rafter. Now I'll feed here 90. I'll click OK, and you can see the changes taking effect immediately. And I'll go to the bolts and I'll use the M20 and the bolt grade of 8.8, and in here I'll use 20 by 250 and 20 2 by 250, and here I'll just feed 0, and in here I'll feed 35, and here also I'll feed 35. Taking into account these are my preferred parameters, and if you intend to use the same, you can apply the same. I'll need a washer on my bolts, and what I'm going to do once again, I'll just go ahead and click modify, and we'll see the changes taking effect immediately. And if you take a look here, the plates are bigger, are spanning out of the rafter extremely bigger. The span is wider. Now what we are going to do is either to come to parts here and change this to 255. We don't need thickness, we'll leave it at default setting, and we'll come here and click modify. So remember, we have to apply all these to all the splice sections. Now I'll come to the second one and I'll do exactly the same thing. I'll press here 90 and come here and also press feed in 90 and come to bolts here and click and select the bolts, the bolt size of M20, the bolt grade 8.8, and I'll feed in here number of bolts at a particular distance, and also I need these bolts at a particular distance, and I don't need that bolts, and I need 35 here, and I need another 35 here, and I need a washer on that particular section. And what I'll go ahead and do is just click modify, and the only thing remaining is the span of this. The width of this plate is bigger, so we need to change it. We come to parts here, and here we'll just feed 255, and we'll go ahead and click modify, and this one will change drastically. So whatever you've forgotten, I think you can notice. If we come back here, you can see we can change the stiffeners here, and that is preferred. That is it's according to your it is an option, and if you don't want to use, you can just leave it at default. Now I'll come to stiffener here, and just to show you how you can change this, I'll click on this drop down arrow here, and we have variety of stiffeners in design and appearance. Now I'll pick on this last option here and come here and select on that also, and click modify, and you'll be able to see how it looks here. And I'll apply all these to the rest of these splice connections. I'll double click here once again and come to stiffeners and select on this and select on that again, and apply by clicking modify for everything to take effect. So I'll come here once again and double click on this on the other side, or the second rafter, and apply all these settings. Remember, they must be the same, because when it lands to workshop, remember, everything must be professionally done and must be uniform. That's how it looks. Double click once again and come to bolts, and bolts here I'll use M20, and the grade will be 8.8, and I'll use 2 meter span, 2 bolts at 250 span, and I'll apply that. I'll just select this and copy paste it here, and I'll change this to 0 and feed 35 here, and also feed 35 here. Remember, they must be uniform, and I'll apply that and go ahead and click modify and see whether it changes. It actually changes, and we have to change the width of the plate. And here we'll just feed to 55. We don't need to mind about the thickness of the plate. Just leave it at the default setting, and we'll come to stiffener here and select the appropriate stiffeners and select on that, and come here and select on that. What you need, once again, we'll just click modify, and everything will adjust itself according to our preferred parameters. Now we'll go to the next splice connection, which is the final one. Then we move to a different step where you'll be able to see how we are going about the next step. I'll double click on this splice connection, and I'll come to picture here and change and define this in accordance to our parameters. I'll apply that by clicking modify, and come to bolts, and I'll pick M20 and pick the grade of the bolt here and pick 8.8. I'll come here and define the number of bolts at a distance of 250 millimeter. So I'll need 2 bolts from that end at a distance of 250, and I need the same distance for 2 bolts at this end. I'll paste that, and these 2 bolts I don't need them, so I'll feed in a 0 distance there, and from this end to the bottom of this rafter, I'll feed 35 right there, and come here and feed 35. And what next? I'll require washers for my bolts. I'll click modify and see the changes taking effect. The next thing we want to change the width of the plate. Click modify and come back again and change the stiffness. I'll apply that design or that look, and this is how it will look on your rafters. So this is how it's done. So remember one thing in your work: don't forget to save your work, because you never know what might happen. You might lose your power supply to your system, or your comp might crash and you end up starting from scratch and redoing whatever you would have done much faster. You start redoing it, and remember, rework is another time wasted and another money lost. Now I'll come here and just to take a look on whatever we've just done, and this is how it looks. Don't worry about the structure you're seeing behind this. That was a different structure from this. Now if we come to the bottom end, the base plates of this, it's easy to modify. You just double click on it, and this dialog box will pop up, and you'll be able to work on it properly by changing the bolts, the bolt grade, the bolt size, the plate size and thickness. The stiffeners you can change here, either to match whatever we've used on the splice joints, or we can just leave it like that. In this case, we can apply that, and we can apply also that one, so that it has a uniform look from the base plate to the splice joints with stiffeners. Now that is how it looks, and that's how it's done. And let's populate this frame along this grid line. Now if I count this, we have how many of these? We have around 15. So what I'll do, I'll just select everything here, then press Ctrl, and then select the grid line to deselect it, because you don't want to populate the grid along the grid itself. It's ambiguous and doesn't make sense. Now I'll right click and come to special copy here and click linear, then come to this dialog box. Prior to populating this along this grid, make sure you check the orientation of your XYZ axis. In this case, we want to populate this along the y-axis, since you can see the x-axis is facing that direction, so the y-axis should be and must be in this direction. So we'll populate this. The distance between this center to that center is 6 meters, and we can confirm that by, again, will require us to deselect whatever we've selected. We'll come to edit, come to distance, then we just want to confirm the distance. This is 6 meters here. So now this 6 meters is what will feed inside here. We'll feed 6 meters here, and we'll feed the number of frames we need to populate along the y-axis here. We need 15 of them. So what I'm going to do is just to click OK here, and give it some time to populate everything along this grid. Here it's how it looks. It's done and complete. Then just go ahead and click OK. Now if I come to view and access the rotate with mouse, and I'll be able to turn this around like this. Let me just redraw this just to remove any signs of modification, and if I turn this around, you can be able to see we have our tapered portal frame of PEB building system, or pre-engineered building system in place. This is how it looks, and this is how this particular tool or macro work much faster and much better. Now this is how it looks, and If you want to download it, don't forget to subscribe. Don't forget to subscribe to our channel. And if you want to access this particular tool, visit our Silvermark site, and you'll be able to download it right from that spot. Now, just look how the frame looks. This is a PEB, or a pre-engineered building system. So these are only frames we've put in place. So we have number of components that needs to be placed. We have the purlins, we have the cladding cladding rails. All those will come in a step by step. So thanks a lot for watching this video, and don't forget to subscribe to this channel, and thanks a lot, and let's meet then. Bye bye.